Hello. Yeah, hi everyone. So my name is Prakash. I am the math tutor for this webinar. I see that few of them has joined. Let's wait for another 15 seconds. Let's see if anybody joins. Then we'll start the webinar. Okay. Yeah. So let's start the webinar then. So today, I hope everyone knows that today we are going to discuss about the how to find the LCM, HCF, and the rules of divisibility. Okay, yeah. So let's start the divisibility rules. So and then we'll discuss about the LCM and HCF. Yeah. Let me share the screen in between. I mean, in between the session. If you have any questions, please feel free to ask me. Okay, if you have any questions. Yeah. So these are the three important things which we are going to discuss today. So one is divisibility, then the least common multiple, and then HCF. Okay. So let's start with the divisibility. I hope you guys are aware of divisibility. What do you mean by a divisibility? Okay, so which is nothing but, for example, if you have a bigger numbers, so how to divide that bigger number using the smaller numbers? Is it possible to divide the bigger numbers by a number? So we just need to check the test. So this is kind of a test, not dividing. This is divisibility is nothing but checking, I mean, checking the numbers, whether that number is divisible by the numbers or not. For example, 483 is divisible by 3. Whether is it divisible by 3 or not? I mean, without dividing a number, we are just trying to find whether it is divisible or not. Okay, just a moment. Yeah. So you can see the definition. It says, easily test if one number can exactly divisible by another. So that's what exactly it means. So exactly divisible means, I hope everyone knows that. So which means it doesn't have any remainder. So we'll ended up getting the whole number, not the decimal answers. For example, you can see the 14 is divisible by 7. 15 is not divisible by 7. If we can divide 15 by 7, but we ended up getting the decimal answer. So that's what exactly divisible means. Okay. So the result has to be whole number without any remainder. Okay. And you can see the third one, 0 is divisible by any number, right? So 0 divided by 7 is 0. 0 divided by any number is 0. So 0 is divisible by any number. So these are the basics you need to remember before we go to the divisibility rules. Okay. So just take a look at the rules of divisibility. So these rules let you test if one number is divisible by the bigger numbers, other, I mean to say. So without having too much calculations, which means we are not dividing, we are just checking the test. We are doing the test, whether it is divisible or not. And make sure that, again, I'm repeating, so the result must be the whole number, and it has no reminders. So 0 is divisible by any number except by itself. I hope everyone knows that. So let's start the test. Okay, so generally the divisibility rule starts for the number 2, the value 2. Why not 1? You might ask me, why not 1? Let me share the whiteboard. So I hope everyone can see the whiteboard. Yeah. So divisibility rule for 1. What is the divisibility rule for 1? It's very straightforward, isn't it? Any number is divisible by 1. That's it. If you take any number, that is divisible by 1. So that's why. So there is no rules because all the numbers are divisible by 1. So as simple by 1. And you can ask me, is 0 is divisible by 1? We'll get infinity though. So that's other case. I mean, except 0. Even 0 is divisible by 1, which results infinity. So except 0, you can take all the numbers which is divisible by 1. The answer is the original number. For example, 11 divided by 1 is 11. So that's why the divisibility rule for 1 is very simple. It's not included in that. Okay. So what is the divisibility rule for 2? What is the divisibility rule for 2? Which means if we have a number, for example, we'll give this number. The question is whether this number is divisible by 2 or not. So how do we know? What is the rule? So we just need to check the last digit of a number, and if the last digit are even, if the last digits are even, okay, so which means the number has to be even, so that's a straightforward one, or else we can call it as the last digit must be even, which means either it has to be 0 or 2 or 4 or a 6 or a 8. Yeah, that's it. So the last digit ends with any of this number. So that's the divisibility rule for 2. Okay, let's try some questions from that. Let's take the same equation. So 492, is it divisible by 2? The question, yes, we can divide this, right? If we divide, let's do it. 2 2s are 2 8s are, and 2 6. You can see that we'll ended up getting a whole number without any remainder. So why this number is divisible by 2? Because the last digit is even, or rather this number is even. And if you have a question, if you get a question like, is this number is divisible by 2? No. Reason, the last number is not even, which is odd. Rather, you can call it as the whole number. The given number is not even. That's why it is not divisible by 2. When we ended up getting remainder or a decimal value. Okay. So that's it of rule 2, divisibility rule 2. For 2, I mean. So what is the divisibility rule for 3? So let's take a random number, 436. Is it divisible by 3? So how do we check? So we are not dividing though, we are just checking how to divide this, whether it is possible to divide this number by 3 or not. So what is the rule says? We just need to add the given numbers. We just need to add the digits of the given number. 4 plus 3 plus 6. We'll get 13, isn't it? So, and if this number, once you added all the digits, if that is divisible by 3, then the original number is also divisible by 3. So in this case, it is not divisible. 13 is not divisible by 3, isn't it? So 436 is not divisible by 3. Let's take a different one. 521, is it divisible by 3? So how do? We are just adding the numbers. 5 plus 2 plus 1. 7 plus 1, 8 is not divisible by 3, isn't it? So 521 is not divisible. So let's take a different number. 3000 of 480 486. So is it divisible by 3? We just need to check. We just need to add each digit, right? So 3 plus 4 plus 8 plus 6. Just try. So we have a 10, 18, 21. So 21 is divisible by 3, isn't it? So 3 sevens are 21, which means this number, the original number, 3486, is divisible by 3. Hope everyone understand. So let's go to the PPT. You can just go ahead and read the first two rules, and I will explain the next one. So what is the divisibility rule for 2? The last number must be even. What is the divisibility rule for 3? We just need to add all the digits of the given number. Then we need to check whether that answer is divisible by 3 or not. If yes, the original number is also divisible by 3. So what is the rules for divisibility rule for 4? So how to find whether the number is divisible by 4 or not? Let's take a number randomly. So this is a bigger number, isn't it? 4-digit number. It takes little time to divide. So instead, what is the rule? What is the divisibility rule? Whether this number is divisible by 4 or not. We just need to pick the last 2 digits of a number. We just need to pick the last 2 digits of a number, which is 52. Then we need to check whether this is divisible by 4 or not. If 52 is divisible by 4, then the given number, the original number, is also divisible by 4. So let's see. So 52 is divisible, isn't it? 4 ones are and 4 threes are. So which means the original number 4852 is also divisible by 4. Let's take the different one. 48,346. Is it divisible by 4? Is it divisible by 4? We just need to take the last 2 digits, which is 46, and we need to check whether that is divisible by 4. 46 is not divisible by 4, isn't it? So we'll ended up getting a remainder or a decimal value. So this is not possible, and this number, the original number, is not divisible by 4. I hope everyone understands the divisibility rule for 4. Okay, so let's take one more. 2,484. Is it divisible by 4? We just need to pick the last 2 digits, which is 84. 84 is divisible by 2, isn't it? Divisible by 4, isn't it? 4 2s are 4 1s are. So the original number 2,484 is also divisible by 4. So I hope everyone understands the first 3 rules. And let's go to the rule 5, divisibility rule for 5. I think everyone knows that the last number, or last digit rather, must be either 0 or 5, right? So that's what is the 5 table says. 5, 10, 15, 20, 25, and 30, and so on, isn't it? So you can see that the last digit must be either 0 or 5. So we just need to check if the number is given. We just need to check the last digit. If the last digit is 0 or a 5, then it is divisible by 5. So in this case, it is not divisible because we have a 2 here. Hope everyone understands that. So another case, 42,860, is it divisible by 5? Yes, because the last digit is 0. So this number is divisible by 5. I think this is a simple one. Let's move to the next one. What is the divisibility rule for 6? So we don't have a separate rule for divisibility for 6. So instead, we can take we can do both divisibility rule for 2 and 3. For example, 4,928. So if this number is divisible by 3, divisible by 2 and 3. So if both satisfies, then only this number is divisible by 6. Let's try. I think you know that the last digit is 8. So 8 is divisible by, that number is divisible by 2. Is it divisible by 3? What is the rule 3 says? Divisibility rule 3. 4, we just need to add the digits and we need to check. So what is 4 plus 9 plus 2 plus 8? So 10, and then we have a 19 and 23. So 23 is not divisible by 3. So the given number, the original number 4928 is not divisible by 6. So it is divisible by 2 but not by 3. So it is not divisible by 6. So if it is divisible by 6, make sure that both the digits must be divisible by, the number is divisible by both 2 and 3. Let's take a different question. So 5,877. Is it divisible by 6? The question. So how to check? We just need to check. Is it divisible by 2? Yes, the last digit is even. So yes, it is divisible by 2. And then is it divisible by 3? We just need to add the numbers. Just try to add. So we have a 10 and then the 22. So we have a 22. So 22 is not divisible by 3. So the given number is not divisible by 3. So it's straightforward. Let's take a different one. Just a moment. 17,631. Is it divisible by 6? Okay, let's take a different one. Sorry. $31,416. Is it divisible by 6? First check. It is divisible by 2. Is it divisible by 3? Let's check. 3 plus 1 plus 4 plus 1 plus 6. We have a 10, 13, 15. So 15 is divisible by 3. So which means this number is divisible by 2 as well as 3. So that means, so this number is divisible by 6. So very simple one. We just need to check rule 2, divisibility rule for 2 and 3. If both satisfies, then the number is divisible by 6. Let's go to the rule 7. What is the divisibility rule for 7? So in this case, a little different than what we discussed so far. For example, if we have any number, we just need to cross out the last digit. Just get rid of the last digit. So what is the last digit? 2. So just cross out 2 and then double that digit. Double in a sense, multiply by 2, isn't it? So 2 becomes a 4. So double it, then subtract it. So just excluding the last digit, okay? We are subtracting because we cancel out the last digit, and then doubled it, which is 4, then subtract. 429 minus 4. We have a 5, we have a 2, we have a 4. So still we don't know whether this is divisible by 7. So try once more. Just cross out the last digit again, which is 5. Then double that number. 5 becomes, if we double 5, it will be 10, right? So then subtract 10 from 42, we'll get 32. I think 32 is a smaller number, I hope. So 30, check whether 32 is divisible by 7 or not. So I think 32 is not divisible by 7. So the original number, the 4292 is also not divisible by 7. Okay, let's take the different example. 1995. Is it divisible by 7? So what is the first step? We're just going to cross out the last digit. Just take rid of the last digit and double that. So 5 becomes 10, right? So then subtract from the remaining digits, remaining 3 digits, which is 199 minus 10, 189. Then still it's a bigger number. So just get rid of the last digit, 9. So then double it, which is so 18 minus 18, 0. I hope everyone knows that. In the first slide I shown you, like 0 is divisible by any number. So 0 is divisible by 7. So which means the original number 1995 is divisible by 7. So this is a rule. So let me explain again to you guys. Just a moment. Let me take one more random number. 39,886. So this is the 5-digit number, as you see. So how to check whether this is divisible by 7? So write down the number, remove the last digit, cross out the last digit, then double that digit. 6 becomes 12, isn't it? Then subtract from the remaining digits. So we'll get 3976. Still the bigger number. So just take rid of the last digit. Again, double it. We have a 12 again. So then subtract again. So we have a 5, we have a 8, and then 3. So still 3-digit number. Just try once more. Remove the last digit, double that, we'll get 10, 5 becomes 10. So then subtract, which is 28. Hope everyone knows that 28 is divisible by 7. 7 fours are 28, right? So the original number is divisible by 7. That's it. So this is the divisibility rule for 7. So let's go to the next one. What is the divisibility rule for 8? So divisibility rule for 8. So little different one compared to the others. We just need to take the last 3 digits of a number. We just need to take the last 3 digits of a number. Then we need to check whether that number is divisible by 8 or not. If yes, then this number is divisible by 8. So I think, little difficult, we can call it as. The reason is we just need to divide 3 digits by 8, that's why, okay? So, but we don't have an option though. So if a number is given, we just need to check whether the last 3 digits of a number is divisible by 8 or not. So this is not divisible by 8. So the original number is not divisible by 8. Let's take the different question. 46,952. Is it divisible by 8? Let's check. Let's take the last 3 digits, 952, and divide by 8. 8 ones are, and then 8 ones are again. We have a 72. We have a 9. So we'll get the remainder as 0. So which means it is divisible. Last 3 digits are divisible by 8. So the original number 46,952 is also divisible by 8. So that's it. So we just need to pick the last 3 digits and we need to check whether those, the last 3 digits are divisible by 8 or not. What is the divisibility rule for 9 then? So, it's similar to rule 3, okay? So what we did in rule 3, we are going to add the numbers, right? Add the digits, right? For example, is it divisible by 9? We just need to add the digits and then we just need to check whether this is divisible by 9 or not. So we have a 8, 10, 19. So 19 is not divisible by 9. So the original number is not divisible by 9. That's it. Let's take the different one. 53,874. Is it divisible by 9? Let's try. So just add all the numbers, all the digits. So we have a 5 plus 3, 8, 16, 20, 27. So you know that 27 is divisible by 9. So the original number is also divisible by 9. So it is more or less similar to divisibility rule for 3. We're just going to add the numbers. If we are able to divide those that result by 9, then the original number is divisible by 9. That's it. So let's go to the divisibility rule for 10. What is the divisibility rule for 10? I hope everyone knows this, because the last digit must be 0. Last digit must be 0. So that's a very straightforward one, isn't it? So it can be 900, it can be 90, it can be 80, it can be 70. So you can see that if the last digit is 10, I think everyone knows that. No need to explain much in this. So if last digit is not 0, then it's not divisible by 10. We'll end up getting the decimal answer or a remainder. Okay. So what is the divisibility rule for 11? This one is interesting. We just need to check, we just need to add even digit numbers or digit numbers. What I mean to say, the position. See, this is at 1, 2, 3, 4, 5. So we have a 5 digits. So in odd placed, we have 4, 4, 4 and 2 toward the even place. So we just need to, we just need to add each one separately. For example, 4 plus 4 plus 4. So these are the odd placed digits. Subtracts. Yeah, subtracts even place digit, which is 2 plus 2. So we have what, 12 here minus 4, which is 8. So 8 is not divisible by 11. So the original number is not divisible by 11. So let me explain with a different example. So 3025, is it divisible by 11? See, this is at, these two are at even places in it. See, odd place. 1, 2, 3, 4. So we are going to add the first digit and the third digit. Then we are going to add the second digit and the fourth digit. And then we are going to subtract. So 3 plus 2 is 5 and minus 5, which is 0. So everyone knows that 0 is divisible by 11. So the given number 3025 is divisible by 11. Let's take the different one. 64,416. Is it divisible by 11? So how to check? So again, I'm saying the first digit, third digit, and first digit, third digit, and the fifth digit, which means odd placed values. 6 plus 4 plus 6 minus even place digit, which is second digit and the fourth digit. 4 plus 1. Then subtract both. So we have a 16 here and we have a 5 here. So which is 11, isn't it? So 11 is divisible by 11. So the original number is divisible by 11. Hope everyone understands this. So finally, what is the divisibility rule for 12? So again, it's a combination of divisibility rule for 3 and 4, which means we are going to check the divisibility rules for both both 4 and 5. 3 and 4, sorry. Okay, let's try some questions in this. So if a number is divisible by 12, then it has to be divisible by both 3 and 4. So you're going to check whether this is divisible by 3. What you do, you're going to add, isn't it? So we have a 10, 15. So 15 is divisible by 3. And we need to check whether this is divisible by 4 or not. So what is the rule for 4? Hope you recall it. We just need to take the last two digits, which is 84. 84 is divisible by 4, isn't it? So the original number, the given number, is divisible by 12. Let's take one more question, just a moment. So 11,820. Is it divisible by 3? Is it divisible by 12? We just need to check the rule for 3 as well as 4. So 1 plus 8 plus 2 plus 0, which is 12. So 12 is divisible by 3. And the last two digits are 20. 20 is divisible by 4. We'll get 5, right? So the original number 11,820 is also divisible by 12. So that's it of divisibility rules, and we do have a rules for 13 and all, but I think this is fine. Up to 12 is fine. So I hope everyone understand. Please let me know. So if you have any questions, so else we'll move to the LCM and HCF part. I will just wait for 30 seconds or so. You can just ask me if you have any questions in divisibility. So these are the rules. Just take a look at it once. Anybody has any questions in divisibility? Okay. So which means I hope everyone understand then. Okay, so I just got one chart. Okay, no. Pradeep, okay, good. So let's go to the next part of webinar, which is LCM and HCF. So LCM and HCF. What is LCM stands for? LCM is least common multiple. HCF is highest common factor. So let's start with HCF, it seems. Yeah, let's start with HCF. So how to find the HCF? Before that, let's try to revise a bit of factors and the common factors of a numbers. What do you mean by a factors? So generally, if you are finding a factors of a number, the product of the numbers must be the original numbers, isn't it? For example, you can see that here 12, 1 times 2 is 12, 2 times 6 is 12, 3 times 4 12. So these are the factors of a number. So 1, 2, 3, 6, 4, 12. So these are the factors of 12. So let's take the different example. Yeah, the factors. What are the factors of let's take 20? So how do you find 20? So how to write the factors of 20? We just directly write by checking whether it is divisible by numbers or not. For example, 20 is divisible by 1. So 1 is a factor of 20. 20 is divisible by 2. So it is a factor of 20. 20 is not divisible by 3. So we are not writing 3. 20 is divisible by 4. So 4. 20 is divisible by 5. It's not divisible by 6 or a 7 or a 8 or a 9. So, but it is divisible by 10. So we already there the half of the mark, isn't it? Half of 20 is 10. So then the final one is 20. 20 is divisible by 20. So these are the factors of 20. So you can find in this way. So the one which I said now, let's try one more. 24 is divisible by 1. So it's a factor. It is divisible by 2. So it's a factor. Is divisible by 3, 4. It's not divisible by 5. I hope everyone. So that's why I just explained the divisibility rules here. So you just need to check the divisibility rules. So 24 is divisible by 4, not by 5, not by, yeah, it is divisible by 6, not by 7, not by, I mean, it is divisible by 8, you can see that, and not by 9, not by 10, not by 11, but it is divisible by 12. So 12 is half of 24, and the next one is 24. So this is one way of finding the factors of a number. So what is the other way? So if you guys facing any problem in this method, you can just try to find the two multiples of this number, or rather two factors which multiplies to this number, like 1 times 24. What else? 2 times 12, 3 times 8. What else? 4 times 6. Do we have any? We have 4 times 6, which is same as this one, right? We have 6 times 4, 4 times 6, both are same. It's just interchanging the values. So let's stop there. So just write all these values 1, 2, 3, 4, 6, 8, 12, 24. I hope everyone understands this term. If you want me to explain using another example, I will do that. So, but this is the easiest two methods we can choose. One is try to find the two factors which multiplies to the original number, like the way I have written here. Or else, if you're confident enough, just go ahead. For example, 36. 36 is divisible by 1. It is divisible by 2. It is divisible by 3. Yeah, 4 is possible. 5, no. 5, no. Yeah, 6 by 6 we can divide. 7, no. 8, no. 9. It is divisible by 9. And then 12. And then 13, 14, 15, 16, 17, 18. It is divisible by 18. So 18 is half of 36. And the next one is obviously 36. So if you're confident enough, just go directly right like this. Then if not, you can do this method. 1 times 36, 2 times 18, and so on. Okay. So whichever is easier to you. Yeah. So this is how we used to find the factors. So how do we compare the factors? What do you mean by comparing? So compare in a sense. So if we have a word called compare, okay. So seems like I got one doubt. No. Anushka raised a hand. Do you have any questions? Please let me know if you have any. So what do you mean by a compare? Compare in a sense, we are comparing the multiple things. It's more than one, right? Always. So if we are comparing something, that must be more than one. So that's what. So let's compare the factors. What common factors? That is nothing but a common factors. What are the common factors of? Can we take the same values? 24 and 36, the one which we did in the previous slide. So what are the factors? Just go ahead and write the factors of 24 and 36 separately. 1, 2, 3, 4, 6, 8, 12, 24. So 36. So let's write the same again. 3, 4, 6, 9, 12, 18, and then 36. So these are the factors of 24 and 36. What do you mean by common factors? Which is common in both the numbers, right? So 1, we have a common as 1. So what are the common factors? What are the common factors of 24 and 36? 1, 2, we have a 3 in both. We have 4 in both numbers. We have a 6. We have a 12. We don't have a 8 or a 9. You can see that. We have a 12, and that's it, right? So these are the common factors. Hope everyone able to follow me. So find the common terms. Finding the common terms of a number is, in a sense, writing the factors of each number separately, then find the common terms of both, common factors of both rather. And then in this, which one is the greatest one? The highest one rather. So that is called as HCF. What is that? Highest common factors. So we can call this as a GCF. What do you mean by GCF? So greatest common factors. But generally in our syllabus, we are going to use HCF. Okay? So it can be GCF, greatest common factor or a highest common factor. So let's try one more. So let's try the HCF. Let's try to find the HCF of 44 and let's take a different question. Sorry. 48 and 72. So what is the HCF of 48 and 72? So one method, you're going to write the factors of 48 and 72 separately. So let me write quickly, just a moment. 4 is possible, 5, 6, 7, 8, 9, 10, 12. And then we have a 16. We have a 24. And we have a 48. So similarly, write the factors of 72. So 1, 2, I think we can divide by 3, by 4, 6, I think, yeah, 8, yes, yeah, 9, yes, 12, 15, 16, I don't think so. Yeah, just a moment, 16, 17, 18. So 18, yeah, 18 is possible because 18 2s are 36. And then after 18, we might have a 24. Yeah. And then we have a 36. Yeah, that's it. The last number, 72. So these are the factors of 72 and 48 respectively. So what do you mean by a common factor? If you get a question about the common factors, you need to write all the common factors like 1, 2, 3, we have a 4, we have a 6 as a common, 8, then 12, what else? We have a 24, that's it, right? So you just need to write all the numbers. If you get a question as a find the common factors, but if you get a question as find the highest common factor, so which is nothing but the highest one. Which one is the highest? 24. So that's the highest common factor, or else you can call it as a greatest common factor. Hope everyone understands this method. So this is one of the method to find HCF. Let me explain the different method for the same numbers. Let's try for the same numbers. So I'm just trying to divide, okay? So I'm just trying to divide. So check whether this, by which number this is divisible. So the smallest number as you think. So which one comes to your mind? So some people might say 4. Yes, that's correct. If not 4, some people might say 2. Let's start with 2. So 24. 2 24s are 48. 2 36 are 72. And the next two numbers, 24 and 36, which is the common number which is divisible by, for both the numbers. So 24 and 36 is both, both divided by 2, isn't it? So again 12 and 18. So yet you might have a question again. So it is divisible by 2 if you want to do, but if you found it both are divisible by 6, that's very good. So 6 2s are 6 3s are. Then that's it. You can see here 2 and 3 is not divisible by any other numbers except 1. So we are not taking 1 because 1 times any number is 1. The original number is in it. So that's it. So finally what we do, we just multiplying these terms. 2 times 6. Try 2 times 2 is 4. 4 6 are 24. So that's a HCF. I hope you guys find the method is simpler than writing the common terms. I hope. Okay, let's try one more question in this. So HCF is 24 here. So it doesn't mean that we'll get the question for only 2 numbers. So compare are a common in a sense. it can be n numbers. It can be 3, it can be 3, it can be 4 or a 5, right? So let's try and find the common terms or a HCF of 3 terms. Okay, let's take the different one, just a moment. Just a moment. Yeah, so let's take 128, 192, then 512. Okay, so if you think of using the previous method, the one which we used here, writing the factors of all three, such as 128, we'll get a lot of factors. 192, we'll get even more than 128. So think of writing factors of 512, we'll get more, right? So instead of that method, let's try in this method, we'll get easily. So check by which number we can divide all three numbers. So let's start with 2. You might say 4, we can, but let's start with 2. We have a 64. We have 28. We have a 96. And then we have a 256. So again, you can check. This is divisible by, all three numbers divisible by 2. You want to try by 4? It's fine. Let's try then. So 4 16s. And then what is 96 divided by 4? 4 2s are, and then 4 24. 256 is divisible by 4 because the last two digits are divisible by 4. So we have a 64 in it. So, but again, you can see that all three numbers is divisible by 4. You can try, or else if you want to try by 2, it's fine. We'll get more steps. That's the only difference. So 4 4s are, 4 6 are, 4 16s are. Do we have any common term in this? Do we have any common term in this? We have, right? We have 2. So 2 2s are, 2 3s are, and then 2 8s are. And finally, we just need to check now, is there any common term to divide for these three numbers? We don't have any. We don't have any common number for 2 and 3 to divide, isn't it? Except 1. So that's it. You just need to stop there, and then whatever the values we got in the left side, just try to multiply. So what is 2 times 4 times 4 times 2? So you can see that 2 times 4 is 8. 8 4s are. Yeah, what is that? 8 4s are 32, and 32 2s are 64. So that's it. The HCF is 64. So this is the easiest method to find HCF. I hope everyone understand, are able to follow me. So please let me know if you have any questions. Don't hesitate to, ask me any questions. So that's it of HCF. This is how we need to find the HCF. You can use any of the methods as you wish, but if you use this method, it hardly takes time, okay? But if you use the different method, the one which I shown in the different slide, the previous slide. So if you get a bigger numbers, it might take a long time, isn't it? Okay, let me share the PPT. Yeah, you can see here. Yeah, just take a look at this. Common factors. So this is what we did, common factors of 12 and 18. So the green one, you can see that. So all those are common numbers. But which one, what is the HCF, which is highest common factors? The biggest one, which is 6. See, you can see that. Yeah. So I hope everyone understands this though. Just a moment. So let's try the LCM now. quickly. So what is LCM? The least common multiple. So before learning the LCM, let's try to revise some basics. Okay, so I got two charts. So please share those recording and PPT so we can practice again. Yeah, sure. So I will inform them to send. Okay, share with you guys. Thank you. Okay, so what exactly I'm saying? Okay, LCM, least common multiple. I hope the last term called a multiple. So you need to learn that first before before LCM. So what do you mean by a multiple? It's a multiples of a number, isn't it? So what are the multiples of 2? You're going to write 2, 4, 4, 6, 8, 10, and so on. So these are the multiples. What are the multiples of let's take a bigger number, 15? You're going to write 15, 30, 45, 60, 75, 90, and so on, isn't it? So the multiples is just kind of a multiplication table. You just need to multiply the numbers. So let's take 35. So 35 ones are, 35 twos are, 35 threes are, 35 fours are, and so on. So this is a multiple. I hope everyone knows this. So if you get a question, write down the multiples of a number. For example, write down the 4 multiples of 35. So you're going to write this 4. That's it. If you get a question, write down 6 multiples of 15. You're going to write 6 numbers, 6 multiples of that number. Okay, what do you mean by a common multiple? Let me explain the same slide. Common multiple. So again, it's the same thing, right? Common. So common between the two. So let's not take 2 here. What is the common multiples of 15 and 35? Do we have any? We don't have any. I think we need to go a little further. So instead, let's take the different question. What is the common multiples of 4 and 5? So what we do, we are going to write down the multiples of 4. 4, 8, 12, 16, 20, 24, and so on. Then 5, multiples of 5, 10, 15, 20, 24, 25, 30, and so on. I think we can stop there. And you can choose, and please check whether we have any common multiple. We have a 20. Okay, for example, if you take 15 and 35, we don't have any so far. So which means we just need to extend the table. We extend the multiples until we get the common one. So, but here we got 20. So that is the common multiple. So, some cases will have few more. You can see that. Sorry. 20, we have a 40 in it. If it goes on, we'll get 40. So these are the common multiples, 20, 40, 60, or 80, and but what is the least one? What do you mean by a least? Smallest one, right? So what is the smallest common multiple? Sorry, common multiple, which is 20. So that is nothing but a LCM. Okay. I think using this method, it will take little time to find LCM though again. So same thing, how to find the LCM, the method 1, writing the common terms of a number. For example, 3 numbers are given. You are going to write the multiples of each number, and then you are going to find the least common multiple. So in this case, so if you want me to write quickly, so we just need to go on until we get the common term. That's the one more thing. So 5, 10, 25, 30. Yeah, so we need to go on. Okay, 6, 12, 18, 24, 30, 36. What else? 42, 48, and so on. So do we have do we have any common multiples of these three numbers? Sorry, I don't think so, right? We don't have any. We have a 20 in these two, but not in 6. We have a 24 in this two, not in this. So we haven't found any, right? So which means we need to go on the multiples until we get that. So which means it might take a longer time, and also we might need to write the more numbers. So what we can do, I mean, we can use this method, obviously. This is one other method. The other method, you're going to use this way. But here, I'm repeating again, please listen carefully. Here, we just need to find the common term of three numbers. If we are not able to find the common numbers of all the numbers, just try to find the common numbers of at least two. See, we can divide 4 and 6 by 2, right? So we can do that. What I mean to say, 4 2s are, and write this 5 as it is since it's not divisible, and then 2 3s are, and then again check whether we have any common numbers between any two of the numbers. We don't have. So what you do, you include this and you multiply. So which is 2 times 2 times 5 times 3. What is the answer? 60, isn't it? So least common multiple, LCM, is 60. So which means you need to write till 16 each one to find the least common multiple if you are using the previous method. But in this method, see how fast we found. Let's try one more question. Can we try a little bigger numbers, for example, at 20 and 24? So how do you find the LCM of 20 and 24? If you're writing the multiples of 20 or a 24, think, I mean, it might take little time and all, right? Because multiples of 20 in a sense, 24 in a sense, 24, 48, 72, 96. So that is little difficult to find, right? We just need to multiply in that case. So better use this method. See what I'm doing here. Just find the common term. So 2 10s are, 2 12s are. We have a 2 again. So 2 5s are, 2 6s are. So that's it, right? 5 6. We don't have a common term. So what is HCF? For HCF, what we do, we are going to take the left side terms, which is 2 times 2 common terms. That is 4. But in LCM case, we are going to multiply this one as well, okay? So which is 2 times 2 times 5 times 6. Okay, that's the only difference you see, you can think of LCM and HCF. In this method I'm talking about. In HCF, we are going to multiply only common terms, which is we divide, I mean the divisor, right? I mean we divided the number. But in LCM, we are going to multiply this numbers, the numbers which we divided, and the reminders which we got, we are going to multiply all. So what is the answer? 2 times 2 is 4, 4 5s are, yeah, 4 5s are 20, 26 are, we have a 120. So 120 is the LCM of 20 and 24. So I hope everyone understand. So that's it of today's webinar. So please let me know. Please feel free to ask me if you have any questions. So waiting for the questions if you have any. You can just unmute your mic and you can ask me. Or else you can ask me in the chat. Anyone has any questions? Okay, so I got one, I think. No from, okay. So no, anybody has any questions? All clear, that's excellent. So which means everyone understand, understand everything, including starting from the divisibility and then HCF and then now LCM. So if yes, then why can't we try some questions? So let's try, let's go for another 5 minutes and try to answer these questions. So please try to answer these questions. Anybody who will answer the first question?
234.
So the reason
234.
is, why the reason? What is the reason?
Because 4 is in the last and 4 is divisible by 2.
Excellent. What about the next one?
582. Add the numbers. 5 plus 8 plus 2. It's 15.
Yeah. So 5 plus 8 plus 2 is 15. So 15 is divisible by 3. So if you think of other numbers, so even if we add, we won't get. We can't divide by 3. That's a nice one. Very nice. Just a moment. Let me go to the different one. Allow me a moment. So here it is. Okay. 582. Okay. So Pradeep answered. Okay, that's nice. So who will answer the next question? What is the divisibility rule for 6? It has to be divisible by 2 as well as 3, isn't it? So what might be the answer? Anyone? You can answer me in the chat, or else you can unmute and you can answer me. Okay, so who will answer? I think
Second one, 678.
Okay, so 678, and I got an answer for 789 from Pradeep. So 789 is not the answer. The reason is it is not divisible by 2. Okay, so that's it. So 678 is divisible by 2 as well as 3, isn't it? So which means it is obviously divisible by 6. Yeah, excellent. Yeah. What about the next one? So the bigger number. Yes, excellent. Exactly.
The last 2 digits.
Okay, the last one you already answered, it seems. Okay. It is divisible by 2 and 3. Which one? You said 64. Excellent. So you took the 64. 64 is divisible by 4. That's excellent. Excellent graph. That's very nice. So let's go to the next slide. Okay, so what you do in the first question. So how that does work. So if a number is divisible by 3, what is your basic step? What do you do?
First, if you want to find a number which is divisible, if you want to find 345,678 is divisible by 3, you have to add up all the digits.
Yeah.
Sum of the digits.
Sum of the digits. The first one, excellent. So sum of the digits. So if we add, we'll get 33. That's what I have written there. Okay, that's very nice. Excellent. So what about the next one? What 9? Similar, I hope, right? Yes, good, Pradeep. Okay. So again, what is the answer for the next one? Same as the previous one, isn't it? Sum of the digits. If you are dividing by 9, same thing. Just add all the digits and check whether it is divisible by 9. Shall we move to the next one? Okay. So, yeah, just take a look at this. 936 is divisible by 6. What is the rule for 6?
If the divisibility rule of 6, it should be divisible by 2 and 3.
Excellent. So which means which is the correct option? Your explanation is excellent. Is correct. So what is the correct answer?
It is even and the sum of the digits is divisible by 3.
Excellent. So even in a sense it is divisible by 2. Sum of the digits in a sense it is divisible by 3. So that's good one. So the final one. If a number is divisible by 6, then it is divisible by 3. Always, sometimes, never, most of the times. I think it's a straightforward question though. It's not the difficult one. What do you say? If a number, for example, 36, if number is divisible by 6, is it divisible by 3? Okay, so I got an answer in the chart. Just a moment. Need to open the chart. Yeah, always. Excellent, excellent, Anushka. Yeah, excellent. So why always? Because if we are dividing by 6, obviously we are using the rules for 2 and 3, right? So obviously it is divisible by 6 always. Excellent. So I think we can, it's divisible by what number? So let's try some LCM questions. Can anyone please tell me what is the LCM of 6 and 8? What is the LCM of 6 and 8? What do you mean by LCM? Least common multiple. So you got an answer from chart. Let me check. 48, excellent. 48 is divisible by 6 and 8. So yes, 48 is correct answer. Excellent. So who will answer the next question? So what is LCM of 9 and yeah, 48 is correct answer of the previous one. What about this one? Next one. Oh, okay. I will enable. Sorry, Anushka. Yeah, I will enable. I think you rejoined. I think that's the reason. Okay, just a moment.
36.
36. So let me check. Yeah, you're right. But I can't see your name, Anushka, in this. So I was not able to, enable the mic. Oh, your mic is not working. Sorry. Okay, that's fine. So what is the next one? Let's try some. Okay. So quickly find the LCM of 3 terms. 6, 8, 9. It might take a little time, but try. 6, 8, 9. 3 2s are 3 3s are. I think that's it. 3 3s are 9, 9 2s are who will answer? 72. I need to check it though. Faster, very nice. What is 2 times 3 times 3 times 8? Oh, I don't think. Yeah, you're right. 72. So what about the next one? Yeah, 72 is the correct answer. That's nice. What is the LCM of 8, 12 and 15. $120. Yeah, that's nice. That's excellent. That's good, Anushka. Yeah, Pradeep, good. Yeah. We're almost done. Okay, thank you. So finally, I have one more slide for HCF. Yeah, the final slide. You can try, and if you want to leave, it's fine. Yeah. We'll answer the first question. So you said 3. 3 is the correct answer, isn't it? So that's the highest common term. What is the common term? What is the HCF of 45 and 105? Pradeep is answered as a 15. Yeah, I think it's 15. 15 is the correct answer. Excellent. So how about 24 and 40? I think 6, right? No, not 6, 8. Yeah, excellent. Okay, you can try that, the questions, and I have a few more slides to try, I think. Yeah. So I will inform them to share this PPT with you guys. You can try these questions and you can refer whenever it required, okay? Yeah, that's it of today's webinar. Hope everyone liked it, and that's it. Thank you, guys. Bye. Take care.
So there's one more question, the last question, fourth one.
You want to try that? Okay, nice. Yes, what's the answer? If you want to try. Okay, you got the answer. That's a 45. I need to check it though. 45 you said. So I randomly taken the questions, okay? So even I don't know the answer. I need to calculate. Okay, so just a moment. 45. I think 45 is the correct answer. Yeah, you're right. Excellent. So that's it. That's it, Anushka. Good. 45 is correct. Okay, then, guys, the students, take care and stay safe. See you in the next webinar, hopefully. Bye, all.